Is all that you dreamed it be.
All right, what I want to do in this video is go through what a ventilatory threshold data output would look like and how to determine ventilatory threshold from that data. So what I've taken is I've gone into the Parvometric system, I selected the participant, and I select Excel export. And from here, I will get Excel data. So I'm going to go ahead and share this. So this is what the data would look like. So we have participant John Doe, blah, 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 and also, and this is what you have to be careful of, is you need to make sure that this is in the same order as what's in the ventilatory threshold file. So in other words, VO2 is first, VO2, and things like that. It'll make sense here in just a second. You can edit the order of events in the Parvometric system. So what I do is I get something like this, and then I'm going to copy and paste it into my VT folder. Let me make sure that I'm definitely sharing the right one now. So I'm going to share it into my VT folder, and I'm going to, at the bottom here, it says raw data. I'm just going to copy and paste it right here. Okay. And then what I'm going to do is go down and find out where the ventilatory threshold stopped. And I have to add in rating of perceived exertion, how many minutes they could sustain. I do that manually at the end of this. And with this participant, I know that RER reached a 1.0 or higher 3 consecutive readings during minute 16. So if I find the RER right here, we have 1, 1, that. So what I'm going to do is, starting at minute 17 and on, I'm not going to take that over. So this VT test only data stops at minute 17. And actually, so anyway, so then from there, this macro just picks it up. So this should be in the same order as what we're seeing right here. So we want to make sure that those are in the same order. And excess CO2, this will mathematically pick it up for us. So these all need to be in that same order. And then it will graph these 3 charts. This is the 3-slope method developed by Steve Gaskell. And from these, and you'll have to go in and edit the time length, because we know that we only went up to minute 17. So I can format the axis and I can change it to 18. So it stretches this out a little bit more properly. Makes it easier to look for any differences. I already went through and did this where I made it so that we eliminated anything that we didn't need. We can format this axis and we could go up to 5. So it's the same. Okay, that looks better. So 1 to 5, 1 to 5. And actually we could do 4.5 on this one. And we could do 4.5 on this one. Whoops. On that axis. Okay. And then I like to draw a line right from the bottom to the top so that it helps you eyeball where we break from linearity better. And then the same thing here. You just format the axis and the time so that we have it so it looks good. We can change this to format axis. We're going to say 17. Okay. And then we should be good. And then what we can do is we look at this and go, when did VO2 start to increase its values without VEV-CO2 increasing? Because this means that when we hit threshold, we start to produce more CO2 because of the buffering of the acid from lactic acid. But that increase in CO2 that we see is accompanied by an increase in breathing rate. So we'll see VEV-CO2 typically stay flat for a longer period of time, but VEVO2, our breathing rate goes up compared to the VO2. So if I needed to, I could put a line in here and go, where does it seem to break from linearity? It seems to break right in here. So that's chart number 1. I would say it's right between 12 and 13. Okay. When does this start to break from linearity? Well, I look at it and go, man, it looks like it stays pretty linear. And then, I mean, you could almost drag that down onto it and go, it starts to break about 3.5. Okay. And then the last one was, when does excess CO2 start to go up? Well, it comes along here and then it just gets tight. Okay. So it starts to get tight. And then from here on, it goes up. So this first little thing, I wouldn't call that the change unless it happened to match up with those other two graphs. But I'm going to go, okay, so we saw here at minute 12, I'm guessing about 3.5. So I'm going to come over to the VO2. And so when did 3.5, when do we start to see us at 3.5? Well, how about that? 3.3, 3.4, 3.4. And then here we go. Around minute 12 is when we finally hit that 3.5 mark. So then the same thing here, I go, man, look at that. That's minute 12 is when it really all of a sudden started to climb up from there. The last thing I can do is go to my VTD only data and say, what happened at minute 12? And at minute 12, what was the RPE? How about that? 12. And they said he could hold it for about 45 minutes. So I feel pretty comfortable saying that this person's ventilatory threshold occurred at minute 12. And what was the heart rate at minute 12? Well, it happens to be about 158, 159 beats per minute. So if I were to have this person do threshold training, I would say, let's have them make sure when they're doing the interval component of it, that they're above about 160. And then when they recover, they go below. I'm betting that this person's sustainable pace or heart rate's like that 155 range, something like that. So hopefully that helps you guys out and helps you to determine how to pick ventilatory threshold from the Excel data.